Going to present instrumentation and control system in plastic bottle filling and capping. DMFD 2433 Instrumentation and Control. Our lecturer is Sir Mahasan Bin Mat Ali. So my name is Muhammad Azmi bin Muhammad Helmi and my partner name is Muhammad Nur Haikal bin Baharudin, Asnur Hakim bin Hassan, Muhammad Arif Shafi bin Ahmad Nizar, and lastly Muhammad Hamidi bin Aznur. So we're going to page 1, table of content. So first is problem description. Second, we're going to talk about detail of proposed instrumentation. Third, predictive maintenance planning. So the first one is problem description. Nowadays, the automation in industry is necessary for accurate and fast production. So let's take an example of soda bottle companies, where the belt conveyor is used for transferring the bottle from one station to another station. So it's like we're going to move a bottle from empty bottle to one station, but before bottle reach at soda filling station, it is necessary to make all the bottle are in standing position for further processing. So we need to make sure the bottle doesn't drop, or what we need to make sure the bottle is standing in the right position on the belt conveyor. Fallen bottle on the conveyor may create problem in next process. So here we discuss a simple PLC logic which handle the fallen bottle. So this is the problem description. Next we go into detail of proposed instrumentation. So for that we are using PLC system that at filling station which reject the fallen bottle from the conveyor and clear the path for the next process. So as you can see at the figure, they have sensor 1, sensor 2, cylinder that want to push the bottle that drop to come down, and the standing bottle is going to go through the conveyor. This process is made by using sensor and actuator. We use pneumatic piston cylinder assembly for pushing the fallen bottle from the conveyor. When conveyor is running, all bottle transfer from one station to another station. For next process, there are two sensors are using for standing and fallen bottle detection. One pneumatic cylinder for pushing the fallen bottle from the conveyor. So that means, like I've said before, the cylinder is made for pushing the fallen bottle to come down into the box, and then the standing bottle that have in the right position will pass through the conveyor. Okay, next I will pass to Asnur Hakim.
Okay, next is a detail of proposed instrumentation. The first figure is the principle of the PLC sensor. Sensors are devices that either measure or detect a physical quantity. A sensor in PLC automation must be a transducer capable of converting a physical amount into an electrical quantity. It is critical to understand that there is no such thing as a one-size-fits-all sensor in this environment. As engineer, we must handle PLC automation difficulties utilizing the appropriate sets of devices, which begin with monitoring the physical circumstance in your system. It is also critical to understand what element to consider while selecting sensor. For the figure 2, diagram of the system. After pressing start push button, bottles are moving on the conveyor belt. Number of bottles passing through the conveyor were counted by proximity switch 1 and proximity switch 2 also. Scanner detect the faulty bottle by providing an input pulse. When scanner detect faulty bottle, then the process should calculate the faulty bottle number by calculating the value of proximity switch 2 and proximity switch 1. Now proximity 2 check the faulty bottle in front of him. When proximity switch 2 detect that faulty bottle, then plunger actuate and push the bottle from the main conveyor to the second conveyor. When we press the stop push button, the total process rests. Okay, next.
Next is predictive maintenance planning about our program. Predictive maintenance is a strategy that employs data analytics to spot abnormality in an operation and potential problem in equipment and process so that they may be fixed before they fail. Predictive maintenance in theory allow the maintenance frequency to be as low as feasible to avoid unforeseen reactive maintenance while avoiding the expense associated with performing too much preventive maintenance. Predictive maintenance anticipates issues by using historical and real-time data. Many sections of business. Predictive maintenance considers three major aspects of an organization, which is the real-time monitoring of asset condition and performance, the analysis of work order data, and benchmarking MRO inventory rate.
Okay. Can you hear me? Okay, from now on I will continue with advantage of sensor device for new improved automation process. Okay, there's a lot of advantage such as accelerate process and make them more accurate. So this means that this process could be very precise, so nothing to be worried about. It collect process asset it collect process and asset data in real time. Also monitor process and asset accurately, reliable and continuously. Increase productivity and reduce total cost of ownership. Also finally lower energy wastage. Okay, next. Okay, next is the limitation of sensor device for new improved automation process. There is not a lot of limitation. There's only three. First is technical complexity because it is hard to understand, so we need experienced people to conduct it. Second is it is power dependent, so it will cost high in electricity bills. Finally, expensive to implement because it takes a lot of component to build it. So I think that is it.
Now I will continue with sensor maintenance. First, adjust alignment. If one of the part is not aligned properly, it is critical to recalibrate and adjust accordingly. To perform this unsuccessfully, you will need the right measurement instrument. Calibration is an instrument is as simple as comparing one proper instrument to the one being prepared. You may use it as a standard for the rest. And number two is keep it clean. Keeping all moving components clean is also essential to ensuring that they do their function appropriately. Make careful to clean any dirt and grease from the sensor at the end of the day. Take the time to educate all workers and staff on the proper cleaning technique. And number three is a proper storage. When your tool is not in use, make sure it is properly stored, depending on the size and placement of the tool. This might involve dismantling it until you need it again, leaving it on the stable surface or covering it with a tab. And number four is a corrosion. Excessive corrosion can cause a machine part to wear out faster. If you can remove the rust on your own, consider hiring a professional or replacing the item totally. Also, keep it moisture away from the instrument as much as possible to avoid it in the first place. And last, know when to replace. Keep in mind that sensor maintenance and cleaning only go so far. If you find yourself realigning or repairing a tool more frequently, that is worth. it is time to replace it. Because before pushes a new model, double check the tool warranty. Okay, that's all from me.
Okay, thank you.
Thank you, Doctor.
Thank you.